they're getting into parallel lines with transversals.
Yes.
Probably one of the most important principles that you can learn in geometry. When you go to take your SAT test, you'll have at least 5 questions on there that require you to understand this one basic principle. Let me go over it, because I know the way they teach it in geometry is in much more detail, and we'll get to that, but I want to make sure you grasp exactly what you get when you have 2 parallel lines and a transversal. You'll notice that you create 8 angles. I'm going to number them.
Okay.
In reality, you only create 2 unique angles, which are 1 and 2 that are supplementary to each other. Every other angle in there is either 1 or 2. In other words, 1 is the same as 4, 2 is the same as 3, 3 is the same as 7, 5 is the same as 1, and one way to figure it out is you almost always have one of the angles is obtuse and one is acute. So if you forget, just check. 8 is an obtuse angle. It's got to be the same as 1.
Okay.
Okay? So that's the essential principle of parallel lines with a transversal, is that you really create 2 angles that are supplementary to one another. 1 plus 2 adds to 180. And then all the other angles there are equal to either 1 or 2. Now, let's talk about some of the terminology they use. Alternate interior angles. Which are those? Give me an example of an alternate interior pair of angles.
Would be 4.
And what else? 4 is definitely, but
6.
you need 2 of them. In other words, these things come in pairs, not 6. And alternate means the other side of the line, the transversal. So 4 and 5 would be alternate interior angles.
Okay.
Notice they're equal. They're both the obtuse. And 3 and 6 are alternate interior. Again, they're called alternate because 3 is on one side of the transversal, 6 is on the other. They're called interior because they all are between the parallel lines. Okay, you with me so far?
Yes.
You also have corresponding angles. Now let's cover alternate exterior. Excuse me for a moment.
Okay.
I want to take these in precise order. Alternate exterior angles, which again, they have to be alternate and they have to be outside the parallel lines. Give me 2 of those.
2 and 7.
Yep. Give me another pair.
1 and 8.
Okay. There's a third category. Corresponding angles. Give me 2 angles that are corresponding.
One and 4.
No, those are vertical. In other words, you've learned that in geometry, haven't you? That whenever you have 2 lines that cross like that, that angle is always equal to that angle, and that angle is always equal to that angle. So those don't have special terminology other than vertical angles.
Okay.
Corresponding angles means they're in the corresponding same position, like 2 and 6. 2 is in that position here. 6 is in the same position.
Okay.
1 down. 4 and 8 are corresponding. 1 and 5, 3 and 7 are corresponding. Now, there's one thing about all three of these. They're all congruent. In other words, in my alternate interior, I got 4 and 5 are congruent and 3 and 6 are congruent. In my alternate exterior, 2 and 7 are congruent, 1 and 8 are congruent. Same thing below. Now, you might say, well, why do they go to all this trouble to name these things this? Why don't we just use the fact that it's either acute or obtuse? And we'll be in the same spot with all this without all this complexity. Here's the reason why. If I draw the two parallel lines with a transversal that is nearly perpendicular, but not quite. There's my 1 and my 2, but I don't know that they're 90-degree angles. One might be 89 degrees, the other might be 91 degrees. So in a situation like this, I can't use my just determine which is the acute and which is the obtuse. The only way I can figure this situation out is with these three theorems. Each one of these is a theorem that alternate interior angles are congruent. And so if I gave you this picture that I've circled, I would know that 3 is equal to 6 without knowing which was the acute. In other words, I don't know which is the acute and which is the obtuse between 1 and 2. So I can't use that rule when I have a near vertical line. If I have a vertical line like this, well, it's very clear which is the acute and which is the obtuse. But because you occasionally have this situation down here, then you have to get into all this extra detail as calling these certain things. That's alternate interior angles. All right. Here's postulate 10. When a transversal cuts parallel lines, then the corresponding angles are congruent. Next one, then the alternate interior angles are congruent. The next one, then the same side interior angles are supplementary. Tell me same side. Give me a same side set of angles. Same side angles.
2 and 4?
Yes. They're supplementary. We knew that because they're, what is it called? Linear angles. They're a linear pair. Same reason 1 and 2 are supplementary. But the same side, I guess that could be called the same side of the parallel line, and that would be called the same side of the transversal, and that would be the same side of the transversal. So you have all kinds of combinations that would be same side angles. But yes, they're supplementary. Excuse my dog howling.
Oh.
And finally, everything, if a transversal is perpendicular to one of the parallel lines, then it's perpendicular to the other also. All right, let's do some of these. We write as we prove this. What's the reason on number 2? Excuse me just a second. Let me blow this up one level here. In fact, let me blow it up 2 levels. What's the reason that angle 1 is congruent to angle 3?
Vertical.
Vertical angles are always congruent. What's the reason 3 is congruent to 2?
Same side.
No, same side angles have to be consecutive and on the same side. Well,
Yeah.
2 and 3 are on the same side, but they're not consecutive. We're missing that angle right below 3. 3 and whatever angle is below 3, that would be same side angles are supplementary. 3 is congruent to 2 because of a previous theorem. Isn't that the way it works? You can only use theorems that you've proven or postulates. Postulate number 10. If 2 parallel lines are cut by a transversal, then corresponding angles are congruent. Well, what we're looking at is corresponding angles. 3 and 2 are corresponding angles. So it's, I guess, postulate 10, excuse me, that was vertical angles. I don't think you have to say postulate 10, but one of the theorems of parallel lines is congruent angles or corresponding angles are congruent.
Okay.
And finally, they didn't make you do much work for number 4, did they? They gave you the statement and the reason. But it's the transitive property. In other words, if 3 is equal to 2 and 1 is equal to 3, then 1 is equal to 2. If something is equal to A and something else is equal to A, then the first something's equal to the second something. Ooh, they're going to make us do all of it here. Okay. This is, we're proving theorem 3.3 that says same side interior angles are supplementary. In other words, 4, well, they're going to make us prove that 1 is supplementary to 4. Okay?
Okay.
And at this point, one of the theorems they've given to us is that alternate interior angles are congruent, correct?
Yeah.
Okay. I think, I mean, I can scroll back here. Anything prior to theorem 3.3, right?
Yes.
Theorem 3.2 is the one we're going to quote. Alternate interior angles are congruent. Since that comes before 3.3, we should be able to use it.
Okay.
Even though, like I said, you're not really going to put down the theorem number. You're going to put down the principle that that theorem said. All right, let's do 1. I'm going to write really tiny. That's as tiny as I can write.
Okay.
Goes over the reason for number 1.
Given.
And given K parallel to line K is parallel to line N, and the transversal T cuts both lines. And we're to prove that 1 is supplementary to 4. So I don't think there's that many steps here. I'm going to put this last step down there. Now, I do it this way. I'm not sure that everybody else does it my way, where I put the proof at the bottom before I do the proof, because it just seems to me that it helps if you know where you're going. I don't know the reason for it yet.
Okay.
So the next thing I can say, they're only showing 3 angles up there, so we must be able to do something with 4 and 2. You could do these in a couple of different orders, but there's 2 steps that have to come before we can get to the 4th step. At least 2. I haven't thought it through enough yet. But can't I say, my next step is 4, angle 4. To me, I'll take this path. Angle 4 is supplementary to angle 2. And the reason is that they are a linear pair. Linear pair angles are supplementary. You know what I mean by a linear pair?
They add up to something.
No, if I have something like this, these 2 angles, 1 and 2 over here on the left, are a linear pair. In other words, they both have a straight line below them. And one of the basic postulates is that linear pairs are supplementary. So I see that 4 and 2 are a linear pair, so I can say that 4 is supplementary to 2 based on whatever theorem says linear pairs are supplementary. Now, what do you suppose the next line needs to be? What's the next statement need to be? Remember, I'm trying to prove something about 4 and 1. So I got to bring angle 1 into the picture here.
Angle 1 congruent to angle 2?
Yes, angle 1 is congruent to angle 2 based on, it was theorem 3.2 when we looked it up, but it basically says that I don't think I should put the theorem even. Let's cross that out. Alternate interior angles are congruent based on theorem 3.2. But we don't need the theorem, we just need to state what the rule is. Alternate interior angles are always congruent as long as 2 lines are parallel. Okay. Now, what should 4 say?
Angle 1 plus angle 4 equals 180. So supplementary.
Well, I think the next step is the proof that angle 1 is supplementary to angle 4 because angle 1 is congruent to 2. So by the transitive property, I may be missing a step here, but I don't. In other words, it's the reasoning that matters. Okay? That's the way I've always felt about proofs. That's the way I will always feel about it. It's not, okay, I missed a line that said something's equal to itself. Big deal. I'm trying to figure out the logic of how I'm going to prove 1 is supplementary to 4. And the logic to me is that if 4 is supplementary to 2, which we know is true, and 1 is congruent to 2, well then 4 has to be supplementary to 1.
Okay.
Based on the transitive property, which is the transitive property says is that if A is equal to C and B is equal to C, then A is equal to B. In other words, if two different things are equal to a third thing, then they're equal to each other. Now, this is not equality. We have this one's supplementary and this one's congruent. So there may be an additional step here that I'm omitting. Trying to think of what it would be. I can't really figure out. There might be a couple things that turn this into a but like I said, if I am missing a couple of lines, they're not really important ones. Do you have answers on these?
No.
Okay, I'd be curious on this one to look it up just to see if we missed a couple. I can't think of what they would be if we did miss some. Oh, let me mention one other thing. There's a corollary to these theorems. And the corollary says is that if I have two lines and I have a transversal and one is not equal to 2, then those two lines are not parallel. In other words, it works in both directions. If the lines are parallel, 1 is equal to 2. If 1 is not equal to 2, then the lines are not parallel.
Okay.
Okay? All right, let's tackle this one. All right. Hold on. I know you know how to do this part, so I will just save time and do it. And we're trying to prove that T is perpendicular to N. We're trying to prove that T is perpendicular to N. Okay. You have any, tell me about logic of how we're going to do this. I don't need to know statements and reasons. I just want you to kind of explain how we're going to get to that proof, that last part. Do you have any idea how to proceed? Okay, what would you do?
Like, don't say the statements and proofs?
I'm sorry, what?
You don't want me to say the statements?
You can do that method if you want. If you know the next statement and reason, go ahead and give it to me. But I'm more interested if you understand the logic behind it. In other words, there's more than just two-column proofs. There's paragraph proofs, and there are what's it called? Flowchart proofs. And both paragraph proofs and flowchart proofs deal more with the logic of how I'm going to get from my given to the proof without worrying about every statement and every reason. I'm just curious if you could do it the other way.
I don't know how to do it the other way.
Let me describe it, and then I'll let you give me all the statements and reasons.
Okay.
I know that line T is perpendicular to line L, correct?
Yes.
Because it shows a 90-degree angle there. And since that's 90 degrees, I know angle 1 is 90 degrees, So I know it's perpendicular to L. Oh, I didn't put all the givens down. These two here. T is perpendicular to L, so that was actually part of the given. And L is parallel to N. Okay. So statement 2 says, I don't need statement 2. It was in the given. I only need one more statement. No, sorry. That's what we're trying to prove. Okay, my bad. Hold on a second.
Okay.
Erase this so I can move it down a little bit. I can't use the theorem we're actually trying to prove as a reason, can I? Which is what I was about to do. I hadn't read the red part of it. Okay, what can we say about angle 1? We have to say this.
The right angle?
Yeah, it's 90 degrees. Based on the fact that T is perpendicular to L. It was based on the given. Then T is also perpendicular to angle 1. What can we say about angle 1 and angle 2?
That they're are they corresponding?
Well, yes, they are, but that means that angle 1 is congruent to angle 2. Based on corresponding angles are congruent when you're dealing with parallel lines. And that is a previous theorem to 3-4. So I can say it, which means that angle 2 is 90 degrees. Based on the transitive property. This transitive property, I may be overusing it, but it's pretty much if angle 1 is 90 degrees and angle 1 is equal to angle 2, then angle 2 is 90 degrees. And I can think of the steps that I might be missing. Yeah, the row I left out that probably needs to be in here is angle 1 is congruent to angle 2, which means the measurement of angle 1 is equal to the measurement of angle 2, definition of congruency. Let me put that in there. I got room. In other words, all of these theorems that we're using here are congruent theorems. They're not equal. So I can't say that angle 2 is 90 degrees yet. I don't think. I think I need this line in here. Measurement of angle 1 is equal to the measurement of angle 2 based on definition of congruent. Now finally, I can say number 5, angle 2 is 90 degrees based on the transitive property. In other words, if the measurement of 1 is equal to 90 degrees and it's equivalent to the measurement of 2, then the measurement of 2 has to be 90 degrees. And finally, line T is perpendicular to line N, definition of perpendicular lines. Means they create 90-degree angles.
Okay.
So let me go back to the beginning and No, I guess I already did that. I already went through the paragraph style of proving that. All right, let's see how many more they're going to have us prove. How many theorems are there here? That was it. So now there must be problems instead of proofs. In class practice, have you done these yet?
I was absent.
Okay. Well, then let's definitely do it.
Yeah.
Here's all we have to do is figure out the answer. We don't have to prove anything. I assume. I don't see any proofs, just maybe you have to deal with your solution. We're given that QRS is perpendicular and that P is parallel with S. So angle PQR is equal to what?
QRS. Angle QRS.
Right, and we know that QRS is 90 degrees, therefore this is 90 degrees.
Yes.
Only because the two lines are parallel, and these are same side angles, or what some people would call consecutive angles. In other words, there's one further category that, hold on a second. Yeah, I can do this. There's one further category in my picture that I didn't cover, and that was consecutive angles. Consecutive angles are also supplementary. And two angles that are consecutive would be 3 and 5, or 5 and 6, or 5 and 7. So that's consecutive angles. They just have to be next to one another. And they're actually supplementary because they're linear pairs, all of them. No matter what consecutive angles you look at, it's a linear pair. So we don't even have to prove that theorem because it's just a bunch of linear pairs. So that's why PQR has to be 90 degrees also. Not because it's equal to angle R, but because they're consecutive angles and they're also same side, which means they have to be supplementary. Q is not always equal to R. If I change the slope a little bit here, if I were to write a line like this, well, then that angle there is not the same as that angle there, but they are supplementary. So it's not that they're equal because they're consecutive, it's that the other one is 90 degrees because they're supplementary. Okay?
Okay.
Now, the next one is, these are more fun. Now we're going to have to write equations. So there's 3 variables here. Let's do it as efficient as possible. Let's figure out what x is. What do you know about that angle right here and this angle?
They're equal.
Congruent?
Yeah.
Okay, yeah, because they're what?
Congruent.
Because they're alternate interior. In other words, I've got actually a bunch of parallel lines here and different traversals. But if I look at line A and line B, then line D is a transversal to those two, right? If I ignore C for the moment, and I just look at this picture right there, I know that 2x has to be equal to 40 because alternate interior angles are equal.
So
So x is 20. Let's label that.
So that makes y 40, right?
Yep. In other words, that's 40 because it's alternate equal to this 40. And now these are still alternate interior, but only if I look at the two different sets of a different set of parallel lines. In other words, now I'm going to look, no, I'm sorry, they're not. They are, I don't know if this one has a name because there are two transversals. Let's see. Let's do Z first. I don't think we have a theorem that makes Y directly equal to 40 because it's part of a different set of parallel lines, unless I'm looking at it incorrectly. I don't think I am. Yeah, no, we can't immediately say Y is 40, but we can say what Z is.
140.
Because it's same side, so it has to be supplementary to the 40. So we know that's 140, and now we can say Y is 40 because Y is a same side angle with Z, regardless of which parallel lines I'm looking at. In other words, if I'm looking at this set of parallel lines right there, that picture, then I know Y and Z are same side. So they're supplementary. You could also, originally, I was looking at this set of parallel lines. So what happens is when they throw a bunch of parallel lines at you with a bunch of transversals, it just generally is a little confusing. Problems that have just two parallel lines and one transversal are really easy. It's when they throw in extra ones that they tend to be harder. What do the arrows tell you?
They're perpendicular. No, they're parallel.
Parallel. Y is 1 congruent to 5. What are they called? Here's where you have to draw on the names.
They're corresponding.
Correct. Y is 3 congruent to 6.
They're alternate interior angles.
Correct. Y is 4 plus 6, 180.
Because they're supplementary.
Because why? Why are they supplementary?
Same side interior angles.
Y is 4, the measurement of 4 is equal to the measurement of 8.
Because they're corresponding.
Correct. Y is the measurement of 4 equal to the measurement of 5.
They're alternate interior
Correct.
angles.
Y is 6 congruent to 7.
They're vertical angles.
Y is K perpendicular to P.
Because of the theorem.
It's the principle.
Transversal.
The transversal is obviously perpendicular to L, and since L and P are parallel, there's that theorem that says is that if a transversal is perpendicular to one of the first line, then it's perpendicular to the other one also. That was, I believe, the fourth theorem, 3.4.
Okay.
Y is 3 supplementary to P. Right.
Because they're same
To 5, yeah. Same side.
interior.
Well, I don't think you even have to say that. Oh, it's same. No, I think it's just same side angles or supplementary.
Oh, okay.
Maybe you'd want to say same side consecutive. Those are consecutive angles. Here's a case where 3 and 5 are consecutive, but they're not linear pair. We can't say they're supplementary because they're a linear pair. We can say 5 and 7 are consecutive and supplementary because they're a linear pair. But 3 and 5 are, we only know that is supplementary because of that theorem that says consecutive angles are supplementary. I don't even remember seeing that in your batch of theorems, but that is a principle that you can use. Angle 1's 130. What's the other numbered angle? What's 2?
50.
What's 3?
50.
What's 4?
130.
5?
130.
6?
50.
7?
50.
8?
130.
Okay. If angle 1 is x, what are the measurements of the other angles?
Would it be 180 minus x for number 2?
Uh-huh.
And 180 minus x for number 3. And x.
Okay. Do one more.
5 is 180 minus x.
Uh-uh. Look at 5, it's obtuse, so is x.
Yes.
They're
Larger.
corresponding angles, so they're equal. And then this one is 180 minus x. That
Okay.
180 minus x. And that one's x. Okay.
Okay.
If angle 4 is equal, if the measurement of angle 4 is equal to twice the measurement of angle 3, find angle 6. So if angle 4 is twice the measurement of 3, how do we figure out angle 4?
You double 50. Well,
Angle 4 is twice the measurement of 3, then 2 times angle 3 plus angle 4 has to be 180. Oh, hold on. I did that wrong. Wrong. Just let me go back here. Angle 4 is twice the measurement of angle 3. And we know that 3 and 4 are supplementary. So I could say angle 3 plus angle 4 is equal to 180. Now I can say angle 3 plus 2 angle 3's, because of this, has to equal 180. Now I got 3 angle 3's has to equal 180. Angle 3 has to be 60.
okay.
Which makes angle 4 120. Now we can see that they are indeed supplementary, and angle 4 is twice the measurement of angle 3.
Okay.
All right. I guess there's one more we didn't do there. If angle 5 is equal to the measurement of angle 6 plus 20, find angle 1. Oh, actually, we didn't even answer the previous one correctly. We solved for angle 3 and 4, but it asked about angle 6. So angle 3 was 60 degrees, angle 4 was 120. What's angle 6?
Wait, can you say it again? Sorry.
We solved, I correctly solved the angle 3 was 60 and angle 4 was 120. But they're asking about angle 6. What's angle 6? Yeah, still on number 12.
60?
Uh-huh. In other words, they're alternate interior angles, so it's got to be the same as 3. And this one's a little similar. They're asking about, they're saying 5 is equal, let me write the equation down. Use this color this time. They're saying angle 5 equals the measurement. I'm going to leave that off just for brevity's sake. What can I do to this? This one's tricky unless I may be thinking about it in the hardest way possible, but I can see a solution. Involves a little bit of trickiness. I don't know. Do you have any ideas? I mean, we don't really have to. Well, yes, we do. We have to state the postulates and theorems that justify all of these things. So what can I say? What can I do? I can add an angle 6 to both sides. I don't know if that's going to be the most efficient way to go, but I know I can do it. So now I have 2 angle 6s plus 20. Okay?
Okay.
Now the addition, the algebraic property of addition. Now, what can I say about angle 5 plus angle 6?
They're supplementary.
Correct? So they and angle 6 is supplementary. Therefore, based on the consecutive angle theorem, it says they're always supplementary, same side, next to one another. Therefore, they equal plus angle 6 equals 180, definition of supplementary. So now my equation reads 180 equals 2 angle 6s plus 20. Now solve it just like any equation. How would you solve for angle 6?
You just subtract 20.
Okay, so 160 equals 2 angle 6s.
And you divide 2. And so angle 6 equals 80.
So angle 6 is 80. That would make the other one 100, angle 5. And that's exactly what they said. Angle 5 is equal to angle 6 plus 20. So we've checked it. So that's correct. And now what's angle 1?
100.
Okay. And again, I'm not sure you could directly say that. Perhaps you can't. We don't have a theorem that relates angle 6 to angle 1. We have a theorem that relates angle 8 to angle 1. We could say that 8 is congruent to 1 based on a theorem. And we can say 8 is supplementary to 6 based on a bunch of theorems or linear pairs. And so then we can say angle 6 is supplementary to angle 1 based basically on the transitive property. I know that to be true, even though I feel like I'm missing a step perhaps in the proof of it. You know what I'm saying?
Yeah.
In other words, can you say that angle 8 is the same, the measurement of angle 8 is the same as the measurement of 1? We can say that. And we can say that 8 is supplementary to 6. Does that necessarily mean that 6 is supplementary to 1? And it is true. I'm just not sure you can state that in 3 steps only, like I just did. Not that important to me, whether or not, I mean, I shouldn't say that.
Okay.
Mathematical proofs are a big subject in more advanced math. But the truth of the matter is that the biggest thing you need to take out of this session is what I started out with. When you have two parallel lines and a transversal, they almost always draw it like this, where the transversal is at an angle. It's not perpendicular, so you're looking at acute angles and obtuse angles. All you got to do is figure out which angles are obtuse, which ones are acute. I'm a little confused here. They give us all 4 statements and all 4 reasons. What's up with that? Oh, he tried to prove postulate 10 as shown below. However, he did not have a valid proof. Why not? He's trying to prove that if 2 parallel lines are cut by a transversal, then corresponding angles are congruent. 1 and 2 are corresponding. Okay, let's look at his proof. First of all, K is parallel to L, given 3 is congruent to 2, based on alternate interior angles are congruent. Not based on postulate 10 alone. Postulate 10 again said alternate interior angles are congruent. Let me look. Postulate 10, corresponding angles are congruent. That's what we're trying to prove.
Okay.
Now, am I correct in that trying to prove postulate 10, we cannot use either of the next 3 theorems?
I don't think so.
Okay, let's see if we can do it. We can't use alternate interior angles, we can't use same side angles or supplementary, and we can't use, if it's perpendicular to one, it's perpendicular to the other. We weren't going to use that one anyway. But, okay, let's see if we can do this. Sorry. Got to go back and find out where I was at.
Yeah.
Okay. It does not have a valid proof. Well, his first statement says angle 3 is congruent to angle 2. We can't use that. We don't know that yet, because we haven't gotten to theorem 3.2, which is the one that says alternate interior angles are congruent. So we can't do it that way.
So that's wrong?
Well, he's telling us this is wrong. He did not have a valid proof. In other words, the proof that they're giving us here is not valid. You can't make statement 2 trying to prove postulate 10. At least I'm assuming that. That's why I went back up and I said, is it true that I cannot use theorems 3.2 and 3.3? And you said you think so. So we're going to try to assume that he did this incorrectly and explain why. I guess we just did.
Yeah.
That's all the further we need to go. You can't say 3 is congruent to 2 yet. You haven't had that theorem. What you could say is that 3 is congruent to 1 because of vertical angles. We've had that.
Okay.
And you could say 1 is congruent to 2. No, that's what postulate 10 is. Yeah, no, we can't use that as the proof to try to prove it. It'd be a nice little trick.
Yeah.
I'll bet he would write something like, ha ha, funny, laugh out loud, LOL. Let's see, what else do we have here? I guess that's as far as we need to go. It didn't actually say present a valid proof, right? Just explain why his proof was not valid. because you can't use that theorem yet. I guess, I don't know, if we look at the document, the postulate's first and the other three are after that, so I'm assuming that we know postulate 10. We had to know postulate 10 in order to prove theorem 3.2. We had to use postulate 10. So I'm assuming the postulate 10 came first and then theorem 3.2, 3.3, and 3.4.
Okay.
We don't have much time. Probably don't want to get into this. We can do this in 3 minutes. Name all angles that are congruent to 2.
So it would just be like to 2?
All lines are parallel. In other words, A is parallel to B and C is parallel to D. So name all angles that are the same as 2.
10 or 5.
Let's go in some sort of order. How about let's go in numerical order?
Okay, so
don't forget any.
Okay, so 4, 5, 7.
2, 4. Yeah, you're right. 4, 5, 7. Keep going.
10, 12, 13, 15.
Yep. Good. Name all angles supplementary to 2.
1, 3, 9, 11.
Well, let's go in numerical order. What about 6?
Oh, I forgot.
So 3, 6.
Yes, 6, 8.
No, not 8. 8's the same as 6. Oh, my bad. Yeah. 8. Go ahead. Sorry.
That's okay. 9, 11, 14, 16.
Yeah. 14 and 16. Is that what you said?
Yes.
Okay. If 13 is 110, then 15 is what?
13 is 110. 15 is 110.
And 3?
100. No, it would just be 70.
Uh-huh. Check to make sure that you're looking for an acute angle. In other words, 3's got to be acute. It's got to be less than 110, otherwise, because we know that it's supplementary to 13. If angle 7, we'll finish on this one. If angle 7 is x, then angle 12 is what?
180 minus x.
7 and 12, what are they?
They're supplementary.
Alternate interior. In other words, I'm looking at this picture right here. Again, I'm looking at those two parallel lines with that transversal. 7 and 12 are the same. So
Okay.
7 is x, then 12 is x.
Okay.
Okay. And 6 would be what?
180 minus x.
Yes. All right. Janessa, I think you got it down. I think you probably might have had it down before we even started, but this
Okay.
couldn't have been bad for you, but hopefully it's helped a little bit.
It has. Thank you.
Okay. I will talk to you next time.
Yes. Bye.